Hello class, this is Marcella again. So this is your second flipped lecture for day 2. So we're going to be talking about growing space. And first to review, let's talk about what trees need to grow. So we'll call these the growth factors. So trees need sunlight, water, nutrients, suitable temperatures, oxygen, and carbon dioxide. And these are really those kind of foundation. These growth factors are common among all plants, all trees. All trees need sunlight, water, nutrients, temperatures, oxygen, and carbon dioxide. They need these things. And we talk about these growth factors, we can think about this idea of the law of minimums. So individuals will use these growth factors until they become limiting. And once they become limiting, that limits growth. So if we look at these barrels are kind of an example of that. So in barrel A, we have light and heat and mechanical support, organic matter, phosphorus, nitrogen, potassium, nutrients, water, and air. We have these growth factors. And in barrel A, we see that phosphorus is limiting. So trees are going to use all these factors until they become limited by phosphorus. So phosphorus is what's limiting right there. Let's say we add phosphorus to the system. We add some nutrients. And we see in barrel B, we added the phosphorus, and now nitrogen is limiting. So there's always going to be something that limits growth. So there's always this limiting factors. And it's going to vary based on where you are in the system, and it's also going to vary temporally, how it varies with succession and change, and also spatially. Sites are variable. Forests are very variable. So talking about this idea of variability in space, we can think of this idea of growing space. And this is a concept that kind of encompasses all these intangible, all these aspects of what trees need to grow. And this is what's on a site. So this is your growing space. And this concept kind of serves as part of the foundation for how we talk about managing forests, how we talk about silviculture. So we're talking about how we manage our growing space. So this is that, yep. So we'll kind of continually talk about this. So growing space varies both spatially and temporally. So we can kind of see with succession how different aspects, how the site, how growing space is used. At first, after a disturbance, we have a lot of space. And what's available for growth is going to really vary based on the disturbance. So was it a harvest? Was it a fire? Was it a flood? Those are all going to influence what's available. And as we see that depending on who gets the site, it influences who's available. And they're using growing space, so that they're using what's there and influencing the site. So we think about growing space and we think about different species. And okay, so this is kind of one of those trick questions. So do you think growing space is different between different species? So yes and no. They're pretty small differences, but when we go back to it, we think about all plants, all trees need these aspects, need all the same growth factors. They need carbon dioxide, they need oxygen, they need nutrients. But there are differences, but pretty small differences when we think about it, in how they use those nutrients. So where these differences occur is how they allocate photosynthate. So do they allocate more to the shoots, to the roots, to the insects and disease resistance? And also the differences occur how they endure low growth factors. but most have similar amounts that will produce optimum growth. Again, that optimum growth may be different between species. So if we go back to the example of the tulip poplar and the Virginia pine from the previous lecture, both of them do grow best both of them use the mesic, well-drained site. That's where both of those species have those optimum growth, that area where they're both growing well. However, they differ in how they allocate some of this photosynthate. So tulip poplar grows quicker, so it's able to allocate more of that growth to height, which allows it to outcompete Virginia pine in that example. So how these differences do occur, and they're pretty small, but they make a difference. So that question was a little bit of a trick question. So you could answer it both yes and no, but it depends. It depends on how we think about that. So growing space and different species. Generally, very, very similar, very small differences, but when those differences occur, we can see those on the landscape, we can see those in a forest system. So we also see variation between areas, so not all areas support the same amount of growing space. And if we look in these two examples, we have one that's pretty green, moist, we've got aspen and spruce and firs, and then we have one that's a lot more open. We see ponderosa pine, we see some juniper, a lot more. So we're seeing differences in the growing space. We're seeing differences in what's available for tree growth. So there's going to be differences in what's limiting. So when we talk about this idea of the law of minimums, maybe in this system we're limited by water. Water may be the most limiting aspect. Whereas in this system, maybe we're not limited by water. Maybe we're limited by something else. And how much growing space is there is going to be different between these two areas based on those growth factors. It's also going to vary as the day within a site daily. So we're going to see differences during morning, during the afternoon when it's hottest. We're going to see those growing spaces change within a site within the day. We're going to see how plants respond. So in the morning, it may be at night. Okay, for example, at night we may be limited by sunlight, whereas during the day we may not be limited by sunlight. We may be limited by moisture, which may cause us to close our stomata and decrease the production of photosynthesis. So these aspects, how a site changes during the day, can influence what's available. We also see this change seasonally, and especially here in Minnesota and other places that have 4 seasons, we see how the seasonal change influences what's available, who is adapted to different seasons. So with spring ephemerals, or with trees, or during the winter, we see most trees are not using the growing space that are available. They've shut down. We also see this as weather fluctuates. So this is a picture taken in Wyoming during the middle of June. So the week beforehand, it was 75 and sunny, and the week later, it snowed about 3 inches overnight and was below 30. So these weather fluctuations are going to influence what's available, the growing space. We got added water, but we also had a freezing temperature. We had a change in the temperature, and that may influence certain species. Certain species may have died because they're more sensitive to increasing temperatures, maybe increasing the amount of growing space, maybe opening up growing space, not increasing, opening up growing space. We can also talk about long-term climate. And in the lake states in this area, we had huge amounts of change with our long-term climate, going from being glaciated to unglaciated. And we see that that has influenced, that has changed our soils, that has influenced what's available, what's on a site, the nutrients that are on the site, the availability of these nutrients. And of course, we can talk about disturbances. Disturbances influence growing space. And we've got two examples. And we have one where we see a pretty extensive harvest and clear cut. And we can think about this one way. We can think about this multiple ways, I should say. We can think about this multiple ways. So in this area, we're on a slope. We're looking down. Right now, we see we've taken off all the overstory. So we've taken off all that vegetation and we've opened up this growing space. However, if we got rain or if we got a really hard rain that causes erosion, we may be losing some of that growing space because we're taking away some of that nutrient. So disturbance can increase growing space by removing vegetation. So if in this example, we have a tree that fell, you create a tip-up mound, maybe there's some mixing of soil, maybe that's opening up some nutrients. This tree that fell is not using the growing space, right? It's dead. This may be opening up growing space for a new individual. It may be opening it up or allowing these other species on the edge to take advantage of this growing space and kind of capture it. So we can think of disturbance as both something that can allow growing space to be opened up, but it also can really change the amount of growing space if we lose some of those nutrients, if we change the site, if we change how the aspects of the site, what's available for an individual tree. So disturbance and growing space, getting at this. When a disturbance kills a plant, it makes growing space available. So we had this disturbance, we had this plant. It was using growth factors. It was using water. It was using nutrients. Now it's not. Now those are up for grabs. That's available growing space. So a new plant or a surrounding plant will expand to reoccupy this newly available growing space. So they're gonna want to take this stuff up. This is really key aspects. So these are nutrients, these are water, these are space. So this is what trees are interacting and competing for. And this idea of both the occupied and unoccupied growing space can change as a forest develops. And we see this with succession. We see that trees influence, that vegetation influences what's available and unavailable. And that's where we get at some of these slight differences. So when we have this very intense disturbance, if we go back to that example of that very intense clear cut where there might have been erosion, there may be the growing space may be severely limited by the amount of nutrients on the site. So it may be a very limited amount of growing space. And that growing space may be captured in species such as grasses or sedges or these very short, not long-lived species. And they may occupy a site. But as they're occupying the site, they're also changing the site. So as they grow, as they die, they're adding nutrients, and that's changing the growing space. And we see that with succession. We see how a site can change and vary. And we also see that with disturbance as it comes and changes the site. So these ideas of occupied and unoccupied growing space can change as a forest develops. And this idea of growing space should be this idea of growing space might be a little fuzzy right now, and that's okay. So this concept of growing space is a big overarching concept, and it's kind of similar to if we talk about a niche or some of these other big all-encompassing concepts. So this is kind of the introduction. So we're gonna keep looking at this, keep talking about growing space, and please ask questions. So again, we're talking about growing space in time, and we see this idea with forest succession and how trees influence the availability and unavailability of growing space. We see how slight differences between individuals can influence, can change. So when we talk about tolerance, we talk about light. So all trees, all plants, all trees need light. But there is a variation in how much light. And we see that in kind of this mature forest, some of these more shade-tolerant species, so species that are able to survive in lower light levels, may be able to take advantage of growing space that's available that some shade-intolerant species may not be. So light may be the most limiting aspect, and the shade-tolerant species may be able to take advantage of, may be better at using that limited quantity compared to a shade-intolerant species. So growing space and the individual plant. So we have this idea of growing space and the stand, growing space and the forest. We also have to think about growing space and the individual. So this is kind of where we're going to, again, kind of balance this growth of the stand versus growth of the individual. And we'll kind of continually talk about this and continually use this as we build our silvicultural toolbox. So growing space, again, the sum of the factors necessary for growth. So that's what growing space is, the sum of the factors necessary for growth, is available when it's present, but not being used by other plants. So we have this garden. So let's think about it as a garden. And when we first plant our garden, we often plant pretty far off, right? If we think about these lettuce plants, when we planted the lettuce seed, super small, we planted them pretty far apart, and when they sprouted, they were just tiny little saplings, tiny little sprouts that came up. And at first you're thinking, wow, I planted them really far apart. But we planted them far apart because they needed to have space available for them to grow. So they needed these factors. They needed this ability to grow. And we can see that when we talk about growing space and competition. So again, generally pretty small differences between species. So we talk about these differences in our shade tolerance, our water requirements, our nutrient requirements. So overall, these are pretty small differences. There are differences, so we do see differences, but they're pretty small. And these differences really come out to play when we talk about how species compete, where species compete best at, what situations they do best at. And this is a good example. It's from Oliver and Larson. So this is kind of an example of this range of soil moisture and how competitive a species is. So if we go back, we looked at Virginia pine and tulip poplar in the last lecture. So let's look at some of these other species that may be in an eastern upland forest or somewhere on the southeast. So we have Virginia pine, and we see it has a huge range of tolerances, right? And where it grows best is these mesic sites. However, tulip poplar grows even better, so it's able to outcompete it. So on both of these, Virginia pine and tulip poplar both want to be on these mesic sites, but tulip poplar is able to outcompete because it's able to use what's available on that site better. And we see this in other places. We see with ponderosa pine and Douglas fir and Graham fir. We see ponderosa pine, again, does best on these mesic sites. We see, again, most species do best on these mesic sites, these ideal growing space areas. They want to be there. However, competition influences who's there. So these are these small differences between species: shade tolerance, water requirement, nutrient requirements. And those allow some species to compete better under certain situations. But in general, we see of these species, they're where they grow best. They grow best on they grow best on these mesic sites. But that doesn't mean that's where we're going to find them. Some species are at these drier, xeric, or more hydric sites because they're outcompeted. So how do plants allocate growth? So they allocate growth in a variety of ways. So when we think about plants, first off, they have to do maintenance. They have to do this maintenance, and that means respiration. That means all this kind of background stuff. Then they can produce fine roots and leaves. So we need roots for water, we need leaves for photosynthesis. So first we have to do the maintenance. First we have to do all that background respiration. Then we can produce more roots for more water or leaves for more photosynthesis. Then we're going to want to produce flowers and seeds. Finally, we're finally moving into height. So we allocate growth to height before we allocate to diameter. And that's going to be important. So we're allocating first before we grow wider, we're growing taller. And then finally, we allocate tree resistant mechanisms. So that's fighting off insects, fighting off diseases. And this one can kind of move around based on what's going on. So when we think about maintenance, so this kind of background, this kind of need, we can think about growing space. So when we have a lot of plants, so we have a lot of tree seedlings here compared to just a lot less tree seedlings over on this few side. So those many plants. So in this situation with many plants, these species are really competing for the amount of growing space there. So they're really competing really hard. And all that might be happening is that these species are using all this available growing space to just do maintenance respiration. So whereas when there's fewer plants, there's more growing space available for them. So they're doing the maintenance. They're putting on new leaves and roots. They're producing fruits and flowers and seeds. And they're growing both in height and then diameter. So when we can see this when we talk about how trees are able to allocate. So and this is really kind of important, this idea of growing space and how trees allocate or how we manage that. So as a silviculturist, we're kind of thinking, one of our goals is to think about how we allocate growing space in a stand, how we influence how trees grow and which trees grow. So in a site that has many, many trees, all that growing space is tied up in going into maintenance, So whereas when there's fewer trees, the trees are able to really go through more of those allocations. So growing space and forest management. So trees generally have similar requirements. We're talking about these growth factors. We're talking about sunlight and water and nutrients. And the variation is in how much. And this really gets at the idea of silvics. So silvics is the study of the life history and general characteristics of forests, trees, and stands, with particular reference to environmental factors as a basis for the practice of silviculture. So silvics is really the study of how much, what life history characteristics, what general characteristics individual tree has. So we use this information to design different treatments. We shift how growing space is allocated. And we can do this to favor one species over another. We can do this to mimic natural disturbances. So in this case, this is an example of longleaf pine down south. And we see, maybe it's not. This is an example of one of the pine species from the southeast. It may be longleaf or it may be loblolly. I'm not remembering right now. So this is one of the species, and we have trees in the overstory, and also we have trees in the understory. So this is an example of how a silvicultural tool, how using different harvest mechanism created or allowed growing space to be opened up. So there's growing space available for these regenerating individuals, right? So if we removed an overstory, we opened up growing space. So that growing space is both being recaptured by these remaining overstory trees and is being captured by these new understory, these regenerating individuals. So we're shifting how growing space is allocated from all overstory to this mix of overstory and understory individuals. And this is thought to favor natural disturbance, since in a lot of these systems, fire was one of the main disturbance agents. So fire shifted how growing space is available.